Hi everyone, my name is Bouliane. Today I'm going to talk about rate limiting access to internal services in a virtual network. The first thing we will see is the layout of our virtual network. I will then speak about an eBPF XDP rate limiter, and then show you the toolchain we use to build, test, and deploy our eBPF programs. In bonus, I added code sample that you can use to inspire yourself. But first, DigitalOcean. We're a cloud hosting company hosting more than 1 million virtual machines over 13 data centers. On each of these hypervisors, we are using Open vSwitch as a building block to build our virtual network. Let's see how it works. We have an Open vSwitch bridge, and all the virtual machines tab interface are plugged into this bridge. Our physical interfaces are also plugged into this bridge. But what is interesting is that our internal services are accessible through network interfaces that are also plugged into the switch. For example, when an HTTP request that wants to reach the metadata service comes from a virtual machine, it will go through the Meta0 interface. Well, as you can imagine, we don't want to have too many packets reaching these services. It's possible to rate limit at the application layer, but in our case, we decided we want to rate limit earlier to make sure that the workload on these services is as low as possible. That's where we decided to use an XDP rate limiter that we attach to these interfaces, like Meta0. Let's see the rate limiter. We have the code here. The first thing that we see is that we're using a hash map to start a MAC address per MAC address state. So where we start, some counters, a timestamp, and the number of packets that is allowed to go through. Here you can see we have the rate limit hard-coded. So there is 100 packets per interval of 5 seconds that are allowed. Well, it's not 100% true, but for our example, that will be true. We're using a token bucket algorithm, which means that when we see the first packet, we initialize a new timestamp. And for all the other packets that we see, we decrease the number of packets that is allowed to go through. When the number of packets allowed to go through reach 0, we check if we are inside this 5-second interval. If we are, we draw the packet. If we're outside this interval, we just initialize a new timestamp and we refill the number of packets that is allowed to go through. We also update statistic, which is awesome because we can extract them and then we can see what is going on per virtual machine. Now let's see the toolchain. We have a makefile here. And this makefile is used to generate the bytecode object using Cilium and eBPF. It's also calling Go code that is used to test the program logic and load the object using the Cilium eBPF library. We also attach the XDP program to the network interface using Netlink. We do all this before deploying to make sure that everything is fine with our application. And this toolchain is a Docker-based environment with a fixed version of eBPF. And you can see here that the entry point of this Docker file will kickstart the makefile we just saw. And now let's see the Go code using the Cilium eBPF. The first thing we do is we call load collection spec, which will parse the ELF object. We then call new collection that will load the program and the maps in memory, which also call the verifier to make sure that your program is safe. So we finish by attaching the program to a network interface using a Netlink library. And still using the Cilium eBPF library, you can test and benchmark your application. Here you can see that we are calling benchmark with a packet we crafted and the number of times we want to send this packet. Using table-driven tests, here we are passing the number of packets we want to send and the outcome we expect. Using this function, you can build very awesome unit tests for your program. And for deploying, it's very simple in our case. We have a bash script that uploads the program object file to an artifact server. This file can be accessed through the git hash or the timestamp. This allows Chef to pull the object file, and using the same Go code we just saw, we put things in place. And in conclusion, we saw our virtual network and how we use the eBPF XDP rate limiter. We also saw the toolchain that we use to build, test the logic, load, verify, and deploy our eBPF application. We saw the awesome Cilium eBPF library, and now you're ready to build your first eBPF program. Thank you.